Hello and welcome to this video on the mean and range. This is part of our Functional Skills Maths Level 1 and Level 2 course. The learning outcomes for this video are to find the mean and range for a set of data. The mean and range come under our data cycle under the processing part. So on previous videos, we've had a question that needs answering, we've gone out and collected the data, and we created displays like bar charts and pie charts. Well, another way of processing the data is to calculate the mean, median, mode, and range. And level 1 only have to calculate the mean and the range, so we're going to look at those two first. The mean is sometimes known as the average. So when you hear people saying the average amount of rainfall in a month, generally they're talking about the mean rainfall. So at level 1, sometimes the mean is referred to as an average. At level 2, you will become familiar with two other averages called median and mode. So the mean is the calculated central point of a range of numbers. And we calculate it by adding all of the numbers together and dividing by the number of numbers. So using a basic example, you can see that we have three numbers, 2, 7 and 9. So we add them together and we get 18. The number of numbers, well, there are 1, 2, 3 numbers. We divide 18 by 3 and it gives us our mean of 6. So you add the numbers together and then divide by the number of numbers. And you can calculate a mean for almost anything that involves numbers. So if you did a survey in the class of how far people have travelled to college, you can calculate the mean distance people travel to college. So we did our survey and we had 35 miles, 5 miles, 6 miles and 18 miles. To find out the mean, we add them together and we divide by the number of numbers that we have. Divide one by the other and our mean distance is 16 miles. Now, you need to think about your answer. Your answer has to be somewhere between your lowest amount and your highest amount. So if you calculate a mean that's outside of those bounds, then it can't be right. So if we calculated a mean and it was less than 5, or it was greater than 35, then we've done something wrong in our calculation. The answer has to be somewhere between your lowest number and your highest number. So think about your answer. Here's some practice for you, just to show you can calculate the mean of almost anything, including percentages, decimals, and all sorts of different types of numbers. A student scores the following marks in her maths exam. A friend has a mean mark of 75%. What is the difference between their mean marks? Don't forget to pause the video to have a go yourself. So the first thing we need to do is find out the mean of our students' data. So we need to add these numbers together. So we get our calculator, if it's in the Calculator Aloud exam, and you get a total, or a sum. So the sum is 504. Now the reason I'm writing that down is because sometimes you're given the data in a table, and rather than rewriting it like I've done here, it's actually quicker to just write the sum. So what you could do is put a plus sign between each of those and put an equals there, and rather than writing them out, so you save yourself a bit of time. So our mean is calculated by the sum divided by the number of numbers. So 1, 2, 3, 4, 5, 6, 7 numbers. If you're doing it in the non-calculator paper, just do long division. So 7 into 5 doesn't go. 7 into 50 goes 7 times, which is 49. That's a remainder of 1, and into 14 twice. So our mean percentage is 72%. Her friend got 75. Our student got 72. So there's a difference of 3%. Let's do another example. The table shows the broadband speeds of a group of residents in a town. What is the mean broadband speed? Now they're in megabytes, so we can just leave them in megabytes, and when we get our answer, just call the mean a certain number of megabytes. So if it's already big, just leave it as it is. Don't put in all the zeros for megabyte. We're required to work out the mean broadband speed. So to do that, we need to calculate the sum of our broadband speeds. So what I was alluding to on the last slide is you write the word sum equals, and then rather than rewriting all of these, we can just add them and put the sum at the bottom of the table, and it'll save us some time. And we end up with a sum of 57.5, and that's megabytes. So to work out our mean, it's our total, which is 57.5, divided by the number of samples. So 1, 2, 3, 4, 5. We can do this manually because we know how to divide decimals. And we get a mean of 11.5, and don't forget it's megabytes per second. So the mean broadband speed is 11.5 megabytes per second. Don't forget the units. We can also calculate the mean of negative numbers if required. So here we have some temperatures that are for Christmas week last year, and what we want to do is work out the mean temperature for the week. Now, don't forget the negative sign indicating a negative number is this button here on your calculator, not the negative button in the bottom right, which is subtract. So this is negative, and this is the function to subtract something. So what we need to do is add the numbers, -4 plus -2 plus -3 plus 0 plus 1 plus -2 plus -4. And we can just stick them in the calculator as they are. So this is how we would put them in the calculator. Watch the button presses so you're doing the right thing. Then press equals, and it gives us a total of -14, a sum of -14 for our data. It gives us a sum of -14 for the data that we've added together. We then need to divide -14 by the number of numbers. 1, 2, 3, 4, 5, 6, 7. So our mean is -2, and don't forget the units, of degrees C. We can also work out the mean of time, so we can add time together and divide by the number of bits of data we've got. Now there's several ways of doing it. You can convert it all into seconds and then convert it back, or you can add the seconds and create minutes. So if we just take the minutes, we have 3 plus 2 plus 3 plus 2. So that's 10 minutes in whole minutes. We then have 58 seconds. We add 5 seconds, and that gives us 1 minute and 3 seconds. We can then add 15 seconds, and we get 1 minute and 18 seconds. And then finally, we add 50 seconds. So of the 50, we take 42 to give us 2 minutes. And then finally, the last 8 seconds to give us 2 minutes and 8 seconds as the total from all of our seconds. Add these two together, and we get 12 minutes and 8 seconds. We divide it by 1, 2, 3, 4 pieces of data. So the 12 divided by 4 gives us 3 minutes, and the 8 seconds divided by 4 gives us 2 seconds. So our mean is 3 minutes and 2 seconds. Now sometimes they can actually give you the mean of the data and how many numbers you have, and what you're looking for is the sum, and all you need to do is simply multiply them together. And here's an example for you. The mean wage for 12 teachers in the staff room is £11,000. What is their total wage? So we take the mean, and because it's a mean, it doesn't mean anything different. It's just the number of teachers and their wages. Do the 12 times 11, which is 121, and then put your 3 zeros down. So the total wages would be £121,000 for the 12 teachers. Here's another example of calculating the total when given a mean. Sheila makes wool jumpers. The jumpers take a mean time of 30 hours each to make. How long will it take her to make 5 jumpers? So 5 jumpers times the 30 hours is 150 hours as the total. So I think what these questions are alluding to is just because you see the word mean, don't panic and start adding and then dividing. Use common sense and say the mean time is the time that I am being given to calculate this question. Now there are 2 top tips for you on calculating means. One's to do with zeros and the other is to do with blanks. Now a couple of slides ago we worked out the mean for some negative temperatures that also had positive temperatures and a 0. Now 0 degrees C was a valid reading, so 0 is valid data. So we counted it as one of our numbers. So when we divided our total of minus 14, we divided it by 1, 2, 3, 4, 5, 6, 7 numbers, because this was a valid number. Even though it's 0, it's a valid number. However, sometimes you're given data tables, and this is a way that people give you data, and you'll end up with a blank or a dash. If you end up with a blank or a dash, it's not included in the data. So here you would add John's numbers together and get a sum of 128. And then you would divide it by 1, 2, 3, 4, 5, 6 numbers. So for John, his mean would be 128 divided by the 6 numbers. However, for Bob, his mean would be his total, which is 139, but this time we would only divide it by 5 because this is not a valid piece of data. So you don't divide by blanks or dashes, but you do divide by zeros. Now let's look at the range of data. The range is defined as the difference between the lowest and highest values within your data set. So here we have some data where we have a range of students' marks. So to work out the range, we look for the highest score, which is 80%, and we take away the lowest score, which is 48%. And that gives us a range of 32%. Here are some different formats of numbers that are asking you to find the range. So find the range for A, B, and C. For A, to find our range, we need our highest number, which is 9.6, and we need to take away our lowest number, which is 3.2. So that gives us a range of 6.4. For B, our range is equal to our highest number, which is 54, take away our lowest number, which is 9, and we end up with a range of 45%. And then finally, because we're dealing with negative numbers, let's look for our lowest number, which is minus 1.7, our highest number, which is 1.3. So our range is the sum of these two gaps, which is 3. So the range is 3. If you did this mathematically, it would be the highest number, 1.3, take away the lowest number, which is minus 1.7. So if you put this into your calculator, then you would end up with 3. Now, range is a measure of consistency. And this is something that you will be asked in the exam, because calculating the range is very easy, but understanding what the range is for is far more important. Let's have a look at this explanation of consistency. So when you look at the range, you have to look at the range within the context of the data it comes from. So you don't just look at the range that you've calculated, you then have to compare it to the data it's come from. And here's an example that exaggerates that point. So my first set of data in brown has got these numbers, 1, 3, 2, 2, 3, 1, 2. So to calculate my range, my highest number is 3, my lowest number is 1, so I have a range of 2. Now, when you look at the number 2 compared to the biggest number of our data, 3, this is quite big compared to the data it's come from. So this means if this is big compared to this, it is inconsistent data. In other words, the range is big compared to the biggest number. Let's look at the data in green, and here we've got some numbers in their thousands. So to calculate the range, which is quite easy to do, we get our largest number, which is 1009, and we get our smallest number, which is 1001. So here we have a range of 8. Now, the range of 8 is actually bigger than the range there. But what you need to do is to compare it to your biggest number. So what is 8 compared to 1009? Well, this is very small compared to the data it's come from. Therefore, this is small, and if you have a small range compared to the data it comes from, it means it's consistent data, which means all of our values are really close together. Because they're in the thousands and we have a range of 8, it means it's very small compared to the data it comes from. So it is consistent data. Let's show you this with another example. We have two darts players, player A and player B. And player A, every time he goes up to throw the darts and throws 3 darts at the board, he scores 100. So he has 4 goes and he scores 100 every go. So his mean is the total, which is 400, divided by the 4 throws, which means he has a mean of 100. His range, well, his highest score is 100, his lowest score is 100, so his range is 0. So this is small compared to the data it comes from. So this is consistent. And that makes sense, because every time he goes to throw the darts, he scores 100, which means he's a really consistent player. Now for our second darts player, player B, he's a bit all over the place. When he goes to throw the darts, he can score a maximum of 180 with the 3 darts, or he can be absolutely rubbish and score 20. So let's work out his mean. So player 2 has a total of 400 on his scores. Divided by the 4 throws gives him a mean of 100 as well. So he has a mean of 100 just like player A. But let's look at his range. His range is, his high score is 180, his low score is 20, so his range is 160. Now this is quite big compared to the biggest number from the data. In other words, if this is big, he is inconsistent. Which makes sense because when he goes to throw the darts, we have no idea if he's going to get the maximum score or a rubbish score. Sometimes you can use the word varied instead of inconsistent. So he is very varied for player B, and he is very consistent for player A. So here's a classic mean and range question that you see quite a lot in exams. It goes through a cycle of asking you to calculate the mean, then calculate the range, and then discuss which player you would pick for your team. So we have 2 players, Jim and Alan. And what we've got to do first is calculate their mean scores. So to save time, I'm just going to write the word sum for all of these numbers, so I don't have to write them out again and put plus signs between them. So Jim has a sum of 244. Alan has a sum of 256. They've both played 5 games, so to calculate the mean, we divide the sum. So for Jim, it's 244 divided by 5, which gives us 48.8. And for Alan, his mean is 256, and we're going to again divide that by 5. And it gives him 51.2. So their means are 48.8 runs and 51.2 runs. What are their ranges? Well, for Jim, his range, his highest score is 55 and his lowest score is 40. So he has a range of 15 compared to the 50, which is our biggest score, so he's consistent. Let's look at Alan. Alan has a high score of 110 and a low score of 1. So he has a range of 109. So this is big compared to the data it's come from. So he's inconsistent. So to answer our final question, which player would you pick for your team? There is no right or wrong answer as long as you justify it. You could say Alan because he has the biggest mean, and there's nothing wrong with that. You could choose Jim because he is more consistent. In other words, every time he goes into bat, he's going to get somewhere between 40 and 50 runs. So this is a classic question that goes from mean to range and then asks you to choose something based on your calculations. And that completes the learning outcomes, which were to find the mean and the range for a set of data. The mean is the calculated center point of our data, so we add them together to get a total and divide by the number of numbers. The range is the highest, take away the lowest, and consistency is what range tells us. So if you have a small number compared to the data you're looking at, then it's consistent. If you have a high range compared to the information it's come from, then it's inconsistent. That completes this video. If you'd like more practice on these topics, please ask your teacher. If you have any questions, again, please ask your teacher. Otherwise, we hope you've enjoyed this video.